Welcome to the Fossil Huntress podcast. Today we're going to talk about Ammonites, one of my favorite fossils and maybe something that you have in your personal collection. Ammonites, or ammonoids, are a group of extinct marine mollusk animals. So they're in the subclass Ammonoidea, in the class Cephalopoda, which probably sounds like Greek to you, but they are a type of sea creature that lived in our ancient oceans. They rose during the Devonian, so about 412 million years ago we start seeing them in the fossil record, and they expanded out and diversified to about 10,000 species. And at some point they went from being the ocean's best predator to its most tasty snack. They're related to octopus, squid, and cuttlefish most closely, and they're also related to Nautilus that are still in the oceans today. So Ammonites went extinct about 65 million years ago, and they came in all sorts of shapes and sizes, very small, very large. There's some the size of tractor tires. And you recognize them by their coiled shape. So they're a coiled shell, and in the end of that shell lived a little squid-like creature or octopus-like creature. So picture all these tentacles coming out of a shell, not along the sea floor, but in the water column. So they were hunters that hunted for plankton and vegetation, fish and crustaceans, similar to the way squid and octopus hunt today, but they were attached to a permanent shell. And that shell grew as they grew, and they lived in the last chamber, the phragma cone of that animal. And as they grew, they would build the next layer of shell and then move into the next piece. In between those chambers, there was little patterns, little kind of squiggly lines called septa. And those septa were to help make that shell strong. So when they were buoyant and went up to the surface and expanded, or went down deeper into the water column to hunt, it would shrink, and those septa, those interlinking lines, would help that shell remain strong. So for the ammonites that went too deep, too fast, their shell would crush, and then we would find them dead on the bottom of the ocean floor. So the purpose of those little septa was to keep them strong. The other thing that those shells had was a little thin tube called a siphuncle, and that passed through all the chambers and through the septa, and that's the way that the ammonites controlled their buoyancy. So now picture a shell in the ocean, little squid guy coming out the end, and he's controlling moving up and moving down in the water column to hunt or find more favorable areas to be by controlling the air through that little tube. So the chambered part of an ammonite shell is called a phragma cone, and it contains a series of progressively larger chambers called camera, and these are divided by those thin walls called septa. And then in between the septa is that little tube, that little siphuncle that controls the buoyancy through pushing air back and forth. And so it helped the ammonites move up and down in the water column and keep them safe when they went to depth so that shell wouldn't crush. But the other interesting thing about those suture patterns, those little septa, on the outside of this shell, you'll see how they sort of crinkle across, and they have all sorts of intricate and complex patterns. And one of the things those suture patterns tell us is the species of the ammonite and what time period they're from. So we can tell if an ammonite is Devonian or Triassic, Permian, Cretaceous, just by looking at the outside suture pattern. So we're going to talk more about that. If you're interested in learning more about ammonites, you're welcome to head on over to the Fossil Huntress blog, fossilhuntress.blogspot.com. There's a couple of posts on there specifically around ammonites and their chambered beauties, and there's one from the 20th of July of 2020 you may want to check out that has some pictorial examples of ammonites that you can look to. So thanks for joining me today, and I'll talk to you soon.